Okay, so this is the 3.6 financial mathematics review for the quiz. We had a couple different situations. We had compound interest formulas. We also have annuities, which are when you have repeating payments going in. And I'll give all the formulas to you. So they're on here as well. So the first one, we're investing $1,200 into an account, 2.7% compounded quarterly. And we need to know how much it'll be worth in 6 years. So in this case, we're going to use the very first formula here because we're compounding quarterly. So that's giving us an end value of 4 times per year. And the other formula with the E in it, we only use for continuous compounding. So if you don't see the word continuous, we don't use that formula. Okay, so let's get this one plugged into. Part A, again, we want to find out how much it's worth. We know what we're starting with is 1,200. Okay, and to figure out the interest being added, we're going to do 1 plus the APR, converted to a decimal, over 4 times per year. And then for how many times will we add interest? It's 4 times a year for 6 years. So that's why it's 4 times 6, or 24. Okay, and I would just simply go kind of order of operations. I mean, you could do it all in one step. I would probably just do the 1 plus 0.027 over 4. Raise that then to the 24th power. And then finally times by the 1,200. And you should get a final answer of $1,410 and 26 cents. Okay. Okay, so that's just your straight compound interest. You put money in one time and let it grow. Okay. Part B then, how long is it going to take to triple our initial money? So in that case, they're giving you like an ending value that they want, and they want it to be 3 times the 1,200, so 3,600. And everything else we still know. We still started with 1,200, same interest rate, still quarterly, so 4 times per year. Now the issue is how many years, so our variable there is now T. Okay, so what I would do in this case is first off, we want to divide by that 1,200. Okay, you just want to get that out of there. So if we divide both sides by 1,200, okay, so just to save some space here, that would divide out. That left side would actually just be a 3 there, right? So 3,600 over 1,200 would be a 3. Inside the parenthesis, let's see, that one's actually it actually ends, so I'm going to actually change it to a decimal. Just remember, if it kept going forever, you would want to just keep it more exact, like a fraction. But in this case, it's okay just to rewrite it as what it actually simplifies down to. And now again, we're looking for something in the exponent, so that's when we're going to go to log form. Okay, so it's going to be log of this base, okay, because that's the thing getting raised to a power, right? So it's log base 1.00675 of 3, and that's going to equal whatever the exponent is, which is 4t in this case. Okay, so to do the logarithm, there's 2 ways to do that, and it's going to be a calculator problem. So I thought I had the calculator open. Okay, so again, let's get that logarithm calculated. So the 2 ways to do that, either do the division problem. Remember, so we're doing this piece right now. On the older calculator systems, you have to do log of 3 divided by the log of the base. But the new softwares do the change of base formula for you in there. So let's do it both ways. Just make sure we get the same answer. So if we just went log of 3 and divided that by the log of that base there, again, which was 1.00675. Okay, that's going to be the answer to that log. And with the newer systems, you can go alpha F2 and just pull up the log base and kind of do it in one step, and where it looks more like it looks on your paper. Put the base in, taking the log of 3, and we should get the same answer again both ways. But again, that is equal to 4t. That's what our equation was set up. So we would just simply divide that number by 4 to solve for t. Okay, so it should take about 40.8 years to triple the money there. Okay, so that can be your answer for part B here. T is approximately 40.8 years. Okay. All right, next problem. We invest $21,000 into an account for 7 years. The current value, or like the later value, is given. what was the interest rate that made this happen, basically. So this is the other case where it's continuous, so we're going to use the formula with the e in it. Principal times e to the RT power. Okay, it's the only time we use the e base is for continuous. And they give us the end value, so 28,500. They gave us the start value of 21,000. Okay, E, we all know that's the 2.71. The exponent, there's rate times time. Okay, we know 7 is the time, but we don't know the rate, so 7R. And we need to solve for an exponent again. So I'm going to do the same thing. I'm going to divide out the initial value. So that 21,000 needs to get divided on both sides. Okay, so let's just do that. Divide by 21,000. So that's going to get this canceled out, basically. Okay, so we have that fraction. And in this case, if you actually do the division, it's like 1.35714. It goes on forever. So let's leave it as a fraction. Okay, and let's change the log form again. Okay, because again, we have a base to a power equaling something. So it's going to be log form. The base in this case is e. Okay, we're taking the log of that fraction, and it equals whatever the exponent is, which is 7r. Okay, so I'm going to change forms. And then again, some of you probably recognize log E. We have a shortcut for that, right? I always like to write it as log E and just change it just so I don't like mix anything up. But that's really just a natural log. And that natural log, of course, can be done on your calculator. Okay, so if you do the natural log of that fraction, I'm showing that as like 0.305 something. And then just divide that by 7 to get R. Okay, and it should end up being about 0.0436. Okay, and that'd be your interest rate, so about 4.36%. Okay, next one, APY and APR. Basically, sometimes banks will give you one, sometimes they'll give you the other. But the problems we've been dealing with, we're assuming that they've been giving us the APR. So to find the APY, the simplest way basically is ask yourself, how much would you earn at the end of a year? So the difference is, in this case, APR is 4.25%, but they're going to compound that every month. So you're going to start earning interest after the first month, and then you're earning interest on that interest. So at the end of the year, you're going to have a little bit more than the 4.25% gained because of that compounding going on. So the easiest way to figure out what the APY was is basically just ask yourself, how much would, just pick like simple numbers, how much would $1 be worth after 1 year? And we're going to see how much it grew, basically. So I just picked nice, easy numbers, $1, 1 year. Okay, and then we'll see how that's going to be a little bit different than the 4.25% at the end. Okay, so let's take $1. We're going to go into the same formula we did number 1, right? $1, 1 plus the APR. Okay, they're compounding monthly, so 12. And that's going to happen 12 times in 1 year. Okay, or n times t, 12 times 1. And if we do the calculations on that, we will find, again, doing the parentheses first, and then just raising that to the 12th power. Oops, I think I've typed the wrong number in. 1 plus 0.0425 over 12. Raise that to the 12th power. I got something like 1.0433, and it keeps going. Okay, and hopefully we can recognize we gained a little bit more than 4.25%. Okay, remember we had $1 to start, so we actually gained this much. So that number there is actually the APY, so it's a little bit more. It's like 4.33%. And again, that's because the 4.25 was getting compounded every month. So I think that's the easiest way I've seen. You can look in the book too. They do a slight variation on the formulas, but that's kind of the way I think of APY. Okay, so again, it should be just a touch higher than the APR, and it is. Okay, so moving to the back of the review here, annuities here. So the difference here, if you ever are making regular payments or regular deposits, so you're not just putting money in once, you're like going to continue to do that. That's an annuity, and it changes things because you can't just take your value times the interest rate, because your value is different every month. You're adding to it. Okay, so there's a couple formulas in here in the book that will be provided. One of them is with future value equaling something, one of them is present value. And the difference is the future value is if you are saving up for something. So you want to have the money in the future. Okay, the other one is if you were to like take out a loan or borrow the money, you owe quite a bit of money at present time, present value. Okay, and your project basically is to have you do one of each. Okay, so let's do one. Let's say we found your dream car, $32,000. Bank's giving you 1.9% APR. Loan is 60 months. What will your monthly payment be? Okay, so you borrowed this money. You took out a loan. Okay, so we're going to use the present value one. Okay, so that present value is the amount you borrowed. Okay, so that's 32,000. Okay, equals the R is going to be your regular monthly payment. That's the thing we don't know. So leave that as a variable. And then the rest of this stuff, 1 minus 1 plus interest rate per period. So 0.019 for the year, so over 12 to make it for the month. And notice the negative is built into the exponent there. N is the number of payments, number of months. So they told you is 60 months. So to the negative 60th. And that whole thing's divided by the same I as we had in the numerator. Okay, and this will be our equation. We're going to try and solve for R. Okay, so it looks really messy. There's a whole bunch of parentheses and everything, but really this entire thing is just some number. Okay, so that's what I'm going to calculate. I'm actually going to do it in 2 steps. And again, you can try and do 1 step with a bunch of parentheses, but I'm actually going to just find the numerator first and then divide by the denominator. Okay, because I don't want to have to use a million parentheses here. Okay, so let's do that. So if we did 1 minus, and then open a parenthesis, so just like it's written, raise that whole thing to the negative 60th. So just to verify for the numerator, I'm getting like 0.09055 something. Divide that by the denominator in parentheses, because it's a fraction too. And I'm getting a value for that whole highlighted thing of about 57.19 roughly. Okay, so right now I'm sitting at an equation that says 32,000 equals R times, again, that whole thing was roughly 57.19, whatever. Leave the whole thing in your calculator, because all we have to do now to get R is divide the 32,000 by that number. Okay, so let's just show you the trick on that. So take your 32,000, and you have it in your calculator, right? So you're just going to be able to hit second answer. And again, I have a different number in there from a previous problem, but that second negative sign is the trick to do that. Okay, and when you do that, I ended up with about, oops, I think I put too many things in there. 32,000 divided by 57.19499, and I got about $559.49. Okay, so 559 and 49 cents. Okay, so that would be the regular monthly payment to pay that off. Okay, next problem, to save for retirement. You begin making monthly deposits of $250. Okay, so you're saving money, so that you're dealing with a future value if you're going to use the formulas. They give you an APR. Okay, we have our regular payment. Part A, create a recursive formula to show how much we would have. Okay, and I even gave you a hint. Let's start with, so at 1 month, we have the $250. So what would be the value of after another month goes by? Okay, so it's going to be like an interest kind of thing. Take the amount in your account, so that 250 comes down here. Add the interest. Okay, it's a 2.25. So we're going to move the decimal, divide by 12 because we're just talking about a month here. But then at the end of that month, we're adding another deposit of 250. That's what's different about the ones before. Okay, and that'll just be some number. So let's calculate that real quick. 250 times the 1 plus 0.0225 over 12, and then add another 250. And for that one, I got around $500.47 when I round it. Okay, and the thing going on here now is when you get to the next month, you need to take that answer from the previous month and times it by the interest, because that's how much is in the account now. It's still getting multiplied by the same interest, and you're still going to add the 250 at the end. But this becomes a recursive sequence because you're using the previous answer to get the next value. So to do recursive sequences, we say something like, what's the formula for the nth term? Okay, so u sub n, we just name it u. And the rule is basically you take the previous term, so u of n minus 1, right? And in this case, it was getting multiplied by that interest form, and we're adding 250. So that would be the recursive formula for a sequence. Okay, and again, as long as you know the previous value, that's what this whole piece is, the previous term. Okay. So on your calculator, let me just kind of refresh how to do a little bit of that. You're gonna have to change modes. It's not in function mode anymore. It's actually sequence mode. So that's the first thing I would want to check. So go into your mode. I think I'd already changed mine, but this needs to be in sequence. Okay, 99% of everything you've ever done has been function mode, but for this type of thing, go to sequence mode. And we're actually just going to go to the y equals then and type in the rule, just like we would for a function. Okay, so I believe I have these in there because I did this problem previously, but first line is your n minimum. I told you guys start with 1 month. Okay, so that goes in there, and then at 1 month the value was 250. And then in the middle spot is where you actually type in the formula. So let me clear that out, show you where that stuff came from again. So we need to do the previous term, so u of n minus 1. Okay, so to get the u is second 7, you'll see the little blue u up there. And to tell it which term number, so I open a parenthesis, the n is kind of like the x, so we use that button, and it's going to know to put an n there because we were in sequence mode. Okay, but we want the term, one term before that, so minus 1. Okay, multiplied by the interest. The 1 point was 225, I believe. Yeah, 225 over 12. And then, of course, add the 250 at the end there. Okay, and that should give us a table. If we go to pull up the table, it should give us the values that we were using before. Okay, so we can see the first two. This one was kind of given to us, but there's the 547 cents that we got and so on. And we could just scroll down as far as we need to scroll down and get a value later, because I think part B asks for 20 years have gone by. So let's look at that real quick. So after 20 years go by, okay, you have a recursive formula. You can go ahead and just scroll down to the appropriate value. Just be careful though, because 20 years is not 20 months, right? So 20 years is actually 240 months. And our n value is in months. So if you scroll down that far, look at the y value, that should give you your answer. What we were doing was actually looking at the graph. It might be easier so you don't have to scroll down as far, and sometimes the table's slow to do all the calculations. So if you want to, once that's in, go ahead and set up a window, an appropriate window, and let's graph the thing. So I set my window this way. I knew I needed to go out to 240 in the n value and in the x maximums. So I just went a little farther out to 250. And I just made my Y max 100,000, and that was just kind of guess and check. If it was too low, I could always change it. But these numbers worked for my window, and I was able to see the whole graph. And this way I can just trace and go to 240. Okay, so if I just hit trace and just type in the X value you want, so the number of months, 240, and it's going to just be a lot quicker to get you the value. Still takes a second, but so there it is, around 75,686. Okay, so that's one way to do it. Let me just show you guys with the formula we can get the same way, because again, it's an option if you want to do it either way. But this one is an example of a future value formula. Okay, so I'm going to go back up to the top where I can see that formula, but do the same problem. So it's actually one of these where you're trying to find a future value. Okay, so again, this is number 5, part B. I'm just doing it up here. The future value is what we're looking for. Our regular payments in this case were $250, so that's R. Okay, it's going to be 1 plus the rate. And again, n was 240, right? That's how many months go by. And we're going to divide by the whole I value again. Okay, and if you were to kind of throw that in the calculator, again, I like to do piece by piece. I would do probably the numerator by itself first and press enter. And then take that answer divided by this fraction again in parentheses. And then times that whole thing by the 250. So let's just verify we can get the same thing here. Okay, so it was 1 plus the 0.0225 over 12. And that was all to the 240th power. All right, and then there was a minus 1 on the outside. Okay, so that should be our numerator. Let me just make sure that was right. Yep, and then we're going to divide by the divide by I again. So throw that in parentheses too. Okay, so that's the big parentheses stuff that needs to get multiplied by R, which again was 250 in this case, and hopefully we get the same answer we got from the graph. And there it is. Okay, so everything worked out nicely. Okay, so that should kind of get you through. Remember, we also did a way to get the explicit formula, maybe a bonus problem. I don't know. So see if we can remember that, the a plus b times r to the x, all that good stuff. So, all right, so hopefully that helps for 3-6.